memory is a very important part of the computing system, and then the how to organize memory is a very important topic as well. So computer memory, you could consider it as a linear array of addressable storages or cells, and then those cell is, for example, a D flip-flop like that. And then memory could be addressable depending on the computing system. The word size could be byte or 2 bytes or 4 bytes and so on, but typically it's a byte addressable, means that each byte has a unique address. The memory is constructed of RAM chips, random access memory chips. That is a physical chips. Often that is referred in terms of length times width. So width means how many bits for each storage there. The length means how many of such storage is there. So if you have a 8-bit machine, 4 megabytes is length, 8 is a bit, RAM chip gives you 4 megabytes of 8-bit main memory locations. So here, let's take a look at the structure of an 8 bytes memory chip. So let's consider that as follows. So 8 byte is the memory size, and then each byte is 8-bit. Then how the memory chip would look like in terms of internal structure. So since we have 8 bytes, so we need 8 bytes. So this is a 1 byte with 8 bits like that, and then each bit is virtually, or something like you can consider as a D flip-flop. So one D flip-flop is a 1-bit storage. So we use 8 of them together to construct 1 byte. So we have 8 of them, 2, 3, 4, 5, 6, 7, 8. So we have 8 bytes. We are considering a typical internal structure of a 8-byte memory chip. Then, since we have 8 bytes, so we need to select one of those to store information or to read information. So we need a 3-bit address. So we have a 1, 2, 3-bit address. Since with a 3-bit address, we can have all zeros or 001, 010, 011, and so on, and then all the way down to 111. So we have 8 different values are possible with a 3-bit information. So using 3-bit address value, we should select one of those. So there should be some combinational circuits which takes 3-bit. Let's call it A0, A1, and A2. And depending on the values of A0, 1, 2, we need to select one of those. So that is called a decoder, so one of the combinational circuit we studied in chapter 3. So decoder is given information is encoded like a 00001 and then 111. Then we need to select which one. So 000 represent which one, 001 represent which one. So the example was 00 means John, 001 means Mary, and so on. So that's a decoding. Given encoded information, we want to tell what is the actual being for that. So use a decoder, 3 by 8 decoder. We use that. So address is encoded. Then we select which byte this address is referring to. So if all A's are zeros, then we say this is the one. Then 001, 010, 011. So similarly, 100, 110, 101, 110, and then finally 111. So using 3 by 8 decoder, we can select one of those ones. Then we need to have something like read or write. So is this for read or write? Then if a reader is a 1, so we read from the memory. If a reader is 0, we want to write that. So there is some read or write control signal there to detect to determine the direction of the information flow. And then address is placed, then we select one of the 8 bytes. Then the data should be available outside that. So now we are ready to draw the outline of the chip. So outline of the chip is something like this. So this green box is inside the chip. So inside the chip we have a decoder, we have a group of flip-flops and the like. Then depending on what you do, read or write, depending on address value, something appears on output as an output. So 2, 3, 4, 5, 6, 7, 8. Let's label as a D0, D1, D2, and then D7. So that's the data is there. So those 8 of them together, so let me choose different color. So those 8 lines for each flip-flop output or input is connected to those lines in parallel, something like this. So this is actually 8 lines is there. Similarly, those 8 lines are connected to this one as well to distribute. So this one also connected, this one connected, this one connected, this one. All of those are actually connected to output of D lines, 8 of D lines. So that's the internal structure of a memory chip. Suppose it's 8 byte. So we have 8 bytes. Each byte has 8 bits, and each bit is a 1D flip-flop. Then we need to select one of the 8. So we need a decoder corresponding size. And then we need to have a read or write control signal, whether to want to store data or read the data. So here 2 things we need to take a look, consider is that how many address lines do we need for this memory. Since this memory has 8 locations, we need 3 bits. Since 3 bit can distinguish one of 8, so number of address lines needed for this memory chip is 3 because we have 8 locations. And then the number of data lines we need on this chip is, since each word is a byte is 8 bits, so we need 8 lines for the data bus. So that's what we observe. So we can easily extend this idea if chip has more than 8 byte or 32 bytes or 1 giga and so on, then we can find how many address we need, how many data lines we need, and the like. So we will take a look into that in next